Okay, here's warm-up number 43. So I'm going to simplify this. I'm going to write this in simple radical form. That means I can't have a radical in the denominator. Okay, so what I want to do, since this is a cube root, I want to get triplets down here. So there's only one 3 down there. I don't have triplets. I can't really break down the 3 anymore. So what I'm going to have to do is clone some more siblings for that 3. So a lot of people will do this on top and bottom. But if you do that, we'll still only have 2 3s down there. We'll only have twins. I need triplets because it's a cube root, okay? So what I really want to do is multiply by the cube root of 3 squared in the numerator and denominator, okay? So on the top, 3 squared is 9, and I don't have any triplets there, so there's nothing else I can do with that on the top. But on the bottom, hey, I've got 1, 2, 3 3s down here now. So now I have triplets, and so I can remove that. So I'll get 2 times the cube root of 9 over 3, and then that's simplified. I want to make sure you look for reducing fractions. Can't reduce the 9/3 because the 9's in the radical and the 3 isn't. So that one is done. Okay. This next one, if I just multiply by root 2 over root 2, I'll still end up with a radical in the denominator. So when you have in the denominator, if you have a complex number like this, where you have a real part and a radical part, what you want to do is multiply by the conjugate of the denominator. And whatever you do to the bottom, you have to do to the top. So on the top, I'm just going to distribute. Okay, and yeah, I have a radical in the numerator, but that's okay. I just need to make sure I don't have a radical in the denominator. So here I'm going to FOIL. So first, 5 times 5 is 25. Outer is going to be positive 5 root 2. Inner is negative 5 root 2. And last, and this is the part I feel like I see the most mistakes on. They've got negative root 2 times positive root 2. Well, a negative times a positive would be negative. And then root 2 times root 2 is just going to be 2 because it's root 4, right? Okay, so the 2 middle terms here are going to cancel each other out. They're opposites, so that's nice. That's always going to happen when you multiply by a conjugate. Leaving the top alone. On bottom, now I've got 25 minus 2. Okay, 25 minus 2 is 23. And I'm checking to see if I can do any more reducing. Can't there, so I'm finished. That will always take care of radicals in the denominator if you multiply by the conjugate of the denominator. Okay. Next up, let's find the inverse. So first thing I'm going to do is switch the x and the y. I'm just going to pretend f of x is y. So I'm going to rewrite this like so. And then I'm going to solve for y. Okay, so I'm going to start by adding 7 to both sides. Okay, and now I will divide the whole equation by 4 to get rid of the 4. And you could write that as x over 4 plus 7 over 4, or you can write it all as one fraction. It doesn't really matter. Got it down to this. Okay, ran out of space. I'll go up here. Now I'm going to take the square root of both sides of the equation so that I'll have just a y over there. And when you do that, remember there's a positive and a negative root. Need the plus minus. That is important. Okay, so I would be okay with an answer like this, and then you'd want to put it back in function notation. But that would be fine. You could also split the radical into top and bottom. So we could write this as that, and then hey, root 4 is just 2. So you could write it like that as well. So, you know, this one or this one, they're both fine, either way. But in the final answer, you want to put it back in function notation. Okay, whoops. Put a box around the whole thing for some reason. All right, there we go. All right, next up, finding the inverse again. So again, I'm going to switch the x and the y. And I'll start solving for y. So I'm going to start by subtracting 7 from both sides here. isolate the radical. Okay, and now I want to get rid of the radical, so I'm going to cube both sides of this. Sorry, you said it's hard to read, but I'm cubing both sides. And then adding 3 to both sides. You could multiply this out into a longer polynomial if you wanted to. I'm just going to leave it like this. So I've got x minus 7 to the 3rd power plus 3 equals y, and then I'll just put that back in function notation. Okay, yeah, again, you could multiply out that binomial, but I'll just leave it like so. Okay, all right, and then some function notation. So I've got f of g of x, so I'm going to start with the innermost piece, the g of x, and replace g of x with 4x minus 1. That's what g of x equals. So this is f of 4x minus 1. Okay. Now that means now this is going to be my input in function f. So the input goes where the x is, so it's going to be 3 times something minus 2. It's going to be 3 times this quantity minus 2. Okay. And this one I would want to simplify this, so I'm going to write it without parentheses by distributing 3. Combining those like terms, and there's f of g of x. Okay, let's try it the other way about. Let's see what we get with g of f of x. I'm going to replace the f of x. F of x equals 3x minus 2. So I'm substituting into the innermost equation first. Now I'm going to input this into function g. So here's where the input goes for function g, 4 times something minus 1. So it's going to be 4 times this quantity minus 1. Okay, it distributes 4. Okay, and then I'll combine the negative 8 and the negative 1. And there we go. Okay, and that's the end of the warm-up. See you next time.